Hi, everybody. My name is Alan McInnes, and today we are going to talk about some new features that we've recently released in Amazon Kinesis to help you make some real-time decisions with your streaming data. I'm a solutions architect here at AWS, and I help customers leverage services like Amazon Kinesis to gain insights in real time to the data that their systems are generating. So over the course of this webinar, we'll be talking about several things. The first thing we'll jump into is a streaming data overview. So we'll take a look at what I mean by streaming data, kind of a couple of examples that'll help us all understand what it is that we're talking about with regards to streaming data. And then we'll take a look at the Kinesis set of services. There's 4 different services that comprise Kinesis, so we'll review those so that we're level set on all the different services that we're discussing today. And then we'll get deeper into the new features. We'll talk about enhanced fan out. That's a new feature for Kinesis Data Streams. We'll talk about delivering your data to Splunk and doing data format conversion using Kinesis Data Firehose. So let's talk about streaming data and why it's important. Streaming data gives you the capability to make timely decisions about your data. So data loses value quickly over time. So if we look at this chart, and this comes from a good paper published by Forrester called Perishable Insights. On the left y-axis, we have the value of data to decision making, and on the x-axis, we have time. And so time-critical decisions need to be made quickly after that data gets generated. So doing things like taking a preventative or predictive action needs to happen very, very quickly after the data. The value in doing that as soon as the data gets created is very, very high. Doing actionable and reactive components also have a lot of value if you can do them quickly after the data gets generated. As the time frame turns from hours to days into months, we're now into our sort of traditional batch business intelligence. And a good example of the two of these and how they can be used together is typically with a credit card transaction or a collection of credit card transactions. I'm sure many of us here on this webinar have credit cards, and probably many of us have received texts or phone calls from our credit card company when they recognize some kind of anomalous transaction on your account. And that's obviously something that needs to be done in a time critical manner. We as credit card customers want to be notified very quickly if there's some kind of anomaly, if the credit card company recognizes something strange happening within our account. But then they still send us at the end of the month a bill that indicates how much we owe. So it's a good example of doing time critical decisions for those anomalous transactions, but then collecting the data and doing a traditional batch job at the end of the month to create our bill. So there's value in both, but some are more valuable than others. So when we talk about collecting the data in near real time to quickly get some insights out of it, we're talking about streaming that data. So streaming means ingesting the data as soon as it gets generated. So in years past, we may have written the data to a relational database, and then we would have done some kind of a ETL job on the back end to take the data out and do some transactions on it, do some transformations on it. And that's still a very valuable process to have. But as far as getting the insights out of that data quickly, we want to stream it and process that data on the fly. So shortly after the data gets created, we want to process it in near real time so we can do some analytics on it. We can do some apply some machine learning algorithms and create the alerts and take the actions that are the most valuable for our customers. There's many different use cases for streaming data, and these are just a few across the spectrum that we see here at AWS. From the left to the right, we have smart home and smart city. This could be anything from streaming video to sensors, sound or temperature sensors, industrial automation in factories. Very common is log analytics, feeding data into data lakes. Very, very common ingestion pattern that we see there. And then IoT analytics. So there's more and more devices that are connected today. Every cell phone is connected. There's plenty of other devices, thermostats. Of course, there's lots of connected speakers. So all these devices are generating data in near real time. And by streaming it, you can get some insights into that data very quickly. So streaming the data with Amazon Kinesis, we have 4 different services that you can use to collect, ingest, persist, and analyze that data. So from left to right, we have the Kinesis video streams. Now, I'm not going to talk much about Kinesis video throughout the remainder of this webinar, but just know that if you have a use case or a requirement where you have a camera and you want to stream the data and persist it durably so you can analyze that data, Kinesis Video Streams is a service that can do that for you very easily and very cost effectively. Kinesis Data Streams and Kinesis Data Firehose, we'll talk in more detail about those today, but Kinesis Data Streams, think of it like the streaming buffer. It'll capture and persist the data that you're generating continuously. And Data Firehose very similarly can capture and persist the data, but it can also deliver it to several different destinations. And I'll get into those details here momentarily. And then the 4th service on this page is Kinesis Data Analytics. So now that you have streaming data through either Kinesis Data Streams or Data Firehose, Kinesis Data Analytics can help you answer questions like, what is the average of this particular field in my data over a 15-minute window? And at the end of that 15-minute window, Kinesis Data Analytics can give you those results in real time at the end of the window without you having to persist the streaming data somewhere else and then running another job to capture that average. So it works together with Kinesis Data Streams and Kinesis Data Firehose to get the real-time analysis of your streaming data. But the features that we're going to focus on today are part of Kinesis Data Streams and Kinesis Data Firehose. So the first feature that we'll discuss is called Enhanced Fanout. So before we get into the details, let's just quickly review Kinesis Data Streams. So Kinesis Data Streams will take data from any number of different input sources. So anything that's generating data in near real time can use one of several different libraries or agents to send the data into the stream. Once it's in the Kinesis Data Stream, it'll be buffered and consumed by a processing tool that you either use, such as a managed service like Kinesis Data Analytics, or that you write yourself, such as custom code on EC2. So here we see 4 different possibilities, but there's any number of different streaming consumers that you can use to process data from a Kinesis stream. And then ultimately, when you're done processing the data, so you've gotten the average, let's say, like I used a moment ago, the average of that value over a 15-minute period, you can output that data to a destination so that you can then do some additional analysis or drive dashboards. There's lots of options for what you do once you've done that analysis. So now that we've kind of gotten a little better idea of what Kinesis Streams can offer, let's take a look at some limitations that exist for a typical sort of non-enhanced fan-out Kinesis stream. So this is what you would get if you were not using the enhanced fan-out features. And it's important to understand this so we can see how the enhanced fan-out features kind of layer on top of this and give you significant benefits. So the Kinesis data stream, which is represented here in the rectangle, a stream is made up of shards. So a shard, the best way to think of that is it is a unit of scale in a Kinesis stream. So a shard can receive as input 1 megabyte or 1,000 records per second per shard. So typically when you are creating a stream, you have an idea of approximately how many records per second or how many megabytes per second you would want to ingest from all your data producers. And then you would create your stream with enough shards to handle that capacity. So in this example, we have one single consumer application called Consumer Application A. And it asks a shard for records. It uses the Get Records API to get records from the shard. And then the response from the service is, of course, the data that was in that exact shard. Now, there are some limitations, and this is what the enhanced fan-out feature helps us to improve upon. So Get Records today has 5 transactions per second per shard and can only return 2 megabytes per second per shard. So with those limitations and with a single consumer application, your consumer application is polling the shard. Therefore, it can ask for data every 200 milliseconds to stay within the 5 transactions per second per shard limit. So typically that's fine. 200 milliseconds is pretty close to real time, and in many situations, that's completely acceptable for the use case. However, as soon as we add more consumer applications, and in this case we have 5 consumer applications, and for simplicity, I didn't show all of the different get records calls on the slides, so just consider that each of these consumer applications are all calling get records, and then the service, the Kinesis Stream service, is returning data to each of these different applications. So with more consumers, there's an increase in propagation delay, and that's because recall that you can only call get records 5 times per second. So if I have 5 consumers, then each can only ask for data once per second. So now on the previous screen where I had 1 consumer asking every 200 milliseconds, in this case, each consumer is asking once per second. So I have a significant increase in latency. And because there's 2 megs per second of egress from a shard to a consumer, if I have 5 consumers, I need to make sure that there isn't more than, say, 400 kilobytes that can be delivered per second to each of those consumers. Otherwise, I'll go above that 2 megabytes per second because it's an aggregate value for that shard. All consumers, all their requests in aggregate can't be above 2 megabytes per second. So with those 2 values, the 5 reads per second and the 2 megabytes per second, you can see that the more consumers I want to add, it adds some complexity to my application. And that's where enhanced fan-out comes into play. So with enhanced fan-out, polling of the data to receive it is no longer necessary. Messages are pushed to the consumer as soon as they arrive in the shard. So in this scenario, I've taken out the additional shards just for clarity. So I have 1 stream with the data producer and a single consumer application. So we have some additional APIs with this new feature, one of which is called subscribe to shard. So in this case, the consumer application will call subscribe to shard, which is exposed to the Kinesis service. Under the covers, this uses the HTTP2 protocol. So that allows the consumer application to have a connection to the shard for up to 5 minutes, and data gets pushed over that connection back to the consumer without the consumer having to ask for new data. So this will show a diagram of how that works. The data producer has created a record. The shard inside of the service, it gets persisted to disk, and then it sends the data to the consumer. As data arrives, it immediately gets sent to the consumer right after it gets persisted within the service. The other significant feature that enhanced fan-out provides is that each consumer application gets a dedicated 2 megs per second of egress per shard. So this will show us how that works. So there's another API called, on the previous slide I showed, subscribe to shard. When a consumer application wants to subscribe to a particular stream, it first calls the register stream consumer API. What happens inside the service is it creates an enhanced fan-out pipe. Now this isn't visible to your consumer, but what it does is it gives a full 2 megs per second egress to that consuming application. So the consumer application will then call subscribe to shard, much like on the previous slide, and the data will get sent to that consumer application up to 2 megs per second. As soon as another consumer application wishes to get the data from that stream, it also makes a register stream consumer call, and then the service will create an EFO pipe specific for that consumer application, and then the consumer application will call subscribe to shard, and the data will be sent to that consumer with a full 2 megs per second egress. So now I can add more and more of these consumer applications, and no longer are they constrained by the 5 reads per second because there's no more get records operation required. There's only a subscribe to shard. And no longer are they limited by the total 2 megs per second per shard egress limitation because of the specific pipe that gets created under the covers for each registered consumer. So with enhanced fan-out, when would you want to use this? Basically, anytime you have 2 or more consuming applications for the same Kinesis data stream, it makes sense to use enhanced fanout. So for now, we have a default limit of 5 registered consuming applications, but more are supported through a service limit increase request. Or anytime you have low latency requirements for your data processing. So messages are typically delivered to the consumer in less than 70 milliseconds. So from the time that the data producer writes it to the stream persists it, and then it gets delivered to your registered consumer is typically under 70 milliseconds. So anytime you have requirements for a low latency data consumer, consider using the enhanced fanout feature. And then to build an enhanced fanout application, we've created a new version of the Kinesis client library. So this is a Java library that you would use to build your application and then deploy it onto EC2 instances. This version is in GitHub, and I've created a link elsewhere in this document that you can get to see the library and make use of it. So Kinesis Data Streams, the pricing, we do have some new dimensions for consumers using the enhanced fanout feature. We charge 1.3 cents per gig of data retrieved, and this is going to be across all of your different consumers, 1.3 cents per gig of data. And then there's a per consumer shard hour. So if you recall, we create an enhanced fanout pipe for each registered consumer. So for every shard in your stream that has a registered consumer, there's a 1.5 cents per hour for every shard in your stream. So the next feature that I'd like to discuss is in Kinesis Data Firehose, and it pertains to delivering your data to Splunk. So before I go into the specifics of how you'd go about doing that, let's just review what Kinesis Data Firehose provides as a service. So very similarly to Kinesis Data Streams, we have our input data sources, and this can very similarly be custom code that you write. We have an agent that you can use that will forward data to Firehose, and we have a collection of SDKs and many different languages that you can use to send data to Firehose. So Firehose has a streaming ingestion front end that will receive your data from your data producers, but it also has an internal managed consumer that will take the streaming data and put it into one of 4 different destinations that you can define. The 4 different destinations that we support are S3, Redshift, Amazon Elasticsearch Service, and the newest one being Splunk. And we'll get into the details of that momentarily. So by delivering your streaming data into these 4 different destinations, you now have numerous tools on the output side that you can use to get some business intelligence, do some data warehousing, and analyze the streaming data after it has been persisted to a durable data store like the 4 that are listed here. So Kinesis Data Firehose Splunk delivery allows you to deliver that streaming data to a Splunk cluster and index and multiple indexes that you own. So it's a pretty straightforward configuration. Essentially, you would create a Splunk cluster, either deploying it on EC2 yourself or using the Splunk cloud, and then taking the information about the HTTP event collector as part of your cluster and using that to configure Kinesis Data Firehose so Firehose knows where to deliver the data. And the data producer can be many different options, as I described a moment ago, but some very common use cases, particularly for delivering to Splunk, is logs that are generated throughout different parts of your AWS infrastructure, such as VPC flow logs, CloudTrail logs, perhaps some application logs that you're creating and sending into CloudWatch logs. So these are very popular data types that often get sent to Splunk for downstream analysis. So how it works is you may need to do data transformation. This is optional. It depends on whether you want to enrich the data before you send it to Splunk, whether you want to add anything in addition, or perhaps do some filtering of the data before you send it to Splunk. So you can leverage Lambda to do that before the data gets delivered to the Splunk cluster. Anything that can't get written to Splunk for whatever reason, if the Splunk HTTP event collector does not respond within a period of time that you can define, Kinesis Firehose will put that data into S3 so you won't lose it. And then optionally, you can choose to put all the raw data that arrives from your data producer into S3 as well. So you can send it to your Splunk HTTP event collector for indexing by Splunk, as well as sending the raw data to S3. So you'll always have that durable storage available to you in S3. Configuring it is very straightforward. Within the Amazon Kinesis Data Firehose console, there's a new section called Splunk Destination. And there's just a few different components that you need to add. Essentially, you need to provide the endpoint. So that's the domain name that represents your HTTP event collector. Choose the endpoint type, either raw or event endpoint. So with raw, you're going to rely on Splunk to inspect the data as it arrives and determine what kind of data it is and put it into the proper Splunk index. Or you can create an event endpoint where you will need to do some amount of formatting of the data before you send it to Splunk. And then there's an authentication token section, of course. You need to have that, you need to provide that to Firehose so Firehose can authenticate correctly to your Splunk endpoint. And then there's some timeouts and some retries that you can configure for how long Firehose will wait for a successful response from the HEC from Splunk, and then how long in total it should wait before it stops sending the data to Splunk in the event of a failure. And after that timeout, it will deliver it to S3. So when should you use Splunk delivery? If you're a Splunk user already, and you are trying to find a very straightforward and simple way to take CloudWatch log data, such as VPC flow logs, CloudTrail logs, and get it into Splunk in near real time for analysis, then you can very easily configure CloudWatch logs to deliver to Firehose, and then you can very easily, as we just showed, configure Firehose to deliver to Splunk. And then if you're already using something like CloudWatch logs to create or to persist things like application or security or error logs, or if you are generating those logs on your servers already, you can consider using something like the Kinesis agent, which will take those logs, forward them to Firehose, and then Firehose will deliver them to Splunk on your behalf. So there's several reasons why you may consider using Splunk delivery in Firehose. And the third feature that we're going to review today is record format conversion, also within Kinesis Data Firehose. So format conversion takes your source data and converts it to a columnar format, either Parquet or ORC, before delivering it to S3. So this is very powerful when you want to do use a Hadoop-based system to do analysis on that data. Hadoop would prefer something like Parquet. It's going to be more efficient, and the files are going to be smaller. So there's a lot of benefits to having Parquet files for your analysis. So it's pretty straightforward, similarly to how we configured Kinesis Data Firehose for Splunk delivery. In this case, we configure our Kinesis Data Firehose for S3 delivery. So I will point out that record format conversion is only available for delivering to S3. So I configure my Firehose to deliver to S3, and then I create a schema in the Glue data catalog. So Glue is a service from AWS that has a few different features, one of which is a data catalog, and allows you to create a database and tables that have schemas that can be used through your data processing solution. And in this case, Kinesis Data Firehose will leverage the schema that you create to convert your data source to Parquet or ORC and deliver to S3. So it looks something like this. First, the JSON data gets created by your producer. The schema then gets used by Data Firehose to convert it to the columnar format. And Firehose, I'll point out, will buffer for a period of time, so it's not going to be one record for S3. You can configure Firehose to say, I want to buffer 10 minutes worth of data, and at the end of that 10-minute period, it will then convert all the data that is buffered in the 10-minute window to Parquet or ORC, whatever you've configured, and then it will deliver those files to S3. So now I have my Parquet files in S3 available for the rest of my solution. And then similarly to Splunk delivery, anything that fails that conversion will go to an error location in S3. So you'll always have the data available, and you can inspect it later to determine why it failed conversion to Parquet or ORC. And then optionally, you can say, I want to put all of my raw data into S3 as well as the converted data into S3. So you can have both. And setting it up is very straightforward. As I mentioned, the first step that you would do is go into AWS Glue and create a table inside of a data catalog. And so in this case, this is an example of VPC flow logs. So you can see my column names and the data types are relevant for a VPC flow log data. And so you take this, once you've configured your schema, then you go into the Kinesis Data Firehose, and you simply tell Firehose that you want, one, to enable record format conversion. You say what is the output format, Parquet or ORC, and then you reference the Glue database and the Glue table that contains the schema so that Firehose now knows how to convert the incoming data. So when should you use this? Delivering to S3 for use by Hadoop. So I mentioned this briefly already, but columnar formats are much more efficient for the Hadoop ecosystem to use. Also, ORC and Apache Parquet are compressed by default. So the size of the files that get created in S3 are significantly smaller than just sending the raw uncompressed data to S3. So ultimately, it will lead to lower storage costs because of the compression. And the pricing for record format conversion is 1.8 cents per gigabyte of data converted. So it's pretty straightforward. This is in addition, of course, to the existing Kinesis Firehose pricing. If you enable data conversion, then this is an additional charge that will be applied to your account. So thanks very much. Any information, all the information about these features is located here. Of course, I don't expect you to read this on the slide, but we will provide this slide deck to you and take a look at these. We've got blog posts and documentation and more detailed information about all of these features. All right, thank you very much for your time. And now we have some time left to take your questions.